Alaikum. Can you hear me?
Walaikum assalam, sir. Yes, sir, we can hear you.
Yes, sir.
Okay. Actually, I had a problem with the what do you call that microphone system. Now it's all right. Everything is fine now. All right. Let's come back to the point. As you know that tomorrow you are going to have the class test 2, and the syllabus will be node analysis and mesh analysis. So last class we have gone through the mesh analysis, and today we'll just go through the super mesh. And after super mesh, then the new topic we are going to start with the superposition theorem, if time permits. And so up to super mesh will be the syllabus from node analysis to mesh analysis. And a couple of problems you can see on the BUX. I hope that you already, the practice problem I'm talking about, you have to go through those practice problems. If you have any problem, just let me know in between. And I already sent you the student tutors contact address and everything, and she had given you the what do you call the tutorial session when the consultation time will be. And I have given her the attendance sheet, and I told her to note it down, those who go to her consultation time and discuss. And I'm pretty sure if you don't go, it means you do not have any problem to discuss. That means all are okay with you. And if not, definitely have to see. And still, if you have problem, you just send an email to me with your problem, or you can talk to me in the class. After the class, we'll discuss your problem. So remember, I'm telling again, after the class, we'll discuss your problem. So if anybody got any problem, you please note it down, bring it in the class, and after finishing the class, we'll discuss about it. Okay, this is the way we'll go, no problem. So let's go with these things. And one more thing I'd like to add, you're going to get invitation from time to time during this semester. Not every day, definitely, but time to time I'll send you the invitation for the seminar. And this is a part of the thing, education in the department as well, that you should attend the seminar in order to know the cutting edge technology, what is going on, because after your completion of the graduation, you have to think for higher studies or R&D or the industrial environment, what is the latest technology going on. All these things you need to attend this sort of seminar. Actually, this is increasing your knowledge, and that's why we encourage you to attend the seminar to get knowledge, expand your knowledge, and be familiar with the cutting edge technology. This is one of the another important thing in university education. So I suggest everybody should attend the seminar. And I noted down, you saw that I have written there the what you call, everybody understood. Okay, thank you very much. Now let us go. We are going to start today, as I told you. Just before starting, I'd just like to take a snapshot of your attendance. All of you, come on. Enamul Haq Ryan, please write your ID number. I told you, welcome to the class. Write your ID number, everybody. I see everybody had written except you. A bit faster. I'm going to take the snapshot. Okay. And nobody, don't move. Everybody just leave it as it is. Okay. And now let's come back to the point. What I'm going to go ahead today with the, okay. All of you can just check whether you can see the screen. Yep. And also you can check the sound is okay as well. Okay. Now, okay.
Sir, there is a current source in the I1, so we.
Okay, can you hear the sound?
Yes,
Yes, sir.
Okay, good, thank you. So everybody should be careful on the way. I'll ask you questions, so you should be ready to answer as well. And if you have any question, you know the system what to do. All right, let's go and start. Thank you very much.
We need not to find the current for that loop because it's already given 8 amperes.
Yes, sir. This is because
Oh, thank you,
the current is at the outermost cell. And why it is happened like that? Because, okay, you can see this thing. Because this guy, if you say 3 ampere, okay, 3 ampere here, yeah, you have to go for it for super mesh thing. I think this thing we are going to do it later, but for this one, what you said, yes, you are right. I1 is here.
Yes, sir.
Yeah, I1 is here. Okay, I'm going to show you what your
Sir,
friend
I have
said.
a
I1
question.
equal to 8 ampere.
8 ampere,
8
yes.
ampere. And this problem is a special problem because there is a current source in between, and this is you have to apply the super mesh, and
Mesh.
that's what yeah, super mesh. That's what we are seeing here in this particular problem. Let's say we can go for this problem. One of the problem I'm going to solve. You will do it by yourself. I think better. Is it okay? You have to now. I need to show you the super mesh you have to
Yes, sir.
apply, because so far whatever the problem I have solved, you can see the previous problems everywhere we have the voltage source, no current source, where there is a uh, mesh current in both sides. This is what we can see here. Over here, this is
No, sir.
no, this is a current source, because so far example, or example number this one, you look at it, if you see, this is the problem we solved, but what is this got? Is it a current source or voltage source?
Voltage source.
Voltage source. So voltage source is there, both side got mesh current. The one side is I1, another side is I2, I3, but we did not have any problem because of the voltage source. Is voltage source both sides, two different current, we don't have any problem. But if this is a current source, then it is a problem. Then you cannot write the KVL. Can you write the KVL if it's a current
No,
source?
sir.
Then what is the voltage across the current source? Is a big problem. So KVL, when you go, then you cannot do it. So whenever a current source is there, so that one side of the current source is one mesh current, another side of the current source another mesh current, then it is a problem. But if this is a current source, this is 7 ampere current source, if it is like that, then what happened? One side is I1 and another side is what? 0 ampere. There is nothing. Are there any mesh current here on the left hand side?
No, sir.
No. So 0 ampere is on the other side. 0 ampere, nothing. So what is the total? I1 minus 0 means I1. So I1 is the current, and which is 7 ampere. 7 ampere and I1. So you can say simply I1 equal to 7 ampere. Full stop. Because this is the current only flow, and this I ampere is giving you that information. That's why your friend told me just now when we were looking at this example, he was telling me this example, last example, I1 value is directly equal to 8 ampere, because this is the current flowing through this, which is 8 ampere. This is what is the current? I1, right? I1. This is I1. This I1. So I1 current is flowing. That means what? I1 and 8. This is 8 ampere. So you can straight away say that yes, I1 value is 8 ampere from here. That's the thing what he said. But I told, oh, there is another problem. Problem is with this 3 ampere a current source. This 3 ampere current source. One side is I2, right? One side is I2. Another side is I3. I2 is one side and another side. But this is a 3 ampere current source, not a voltage source. But we have seen only the voltage source. That's why you cannot find the KVL equation here. Can you? KVL, very hard. How come you can write the KVL equation? This is plus minus voltage. This is plus minus voltage. When you write the KVL, what is the voltage across 3 ampere? Anybody can tell me? Is it 3 ampere voltage source? 3 into I3 minus I2. Is it the 3 ampere voltage? The voltage drop across this 3 ampere? Is it? Hey,
No, sir.
no, because 3 ampere, 3 into current, 3 ampere into current cannot be voltage. It is resistance, not resistance. So you understand it? This is not possible.
Yeah.
That's why you have to apply the super mesh here. Super mesh. So super mesh, I'm going to show you now, and you have to solve it by yourself. I'm not going to ask you to solve this problem for the super mesh. Rather, I think you better can go ahead with this one. All of you can just check whether you can solve it or not. Okay, I'm going to give you first this one. Let's start with this one. Look at this problem. Everybody will be, everybody will understand clearly about this problem. Now, if you get it, then how will you solve this problem? How many loops are there? Can you tell me? Hey, come on, first.
3 loops.
3 loops. And when you are going to write the loop current, you can see in the first loop when you are writing it, can you write the loop current for this KVL? You cannot write the KVL one. Why you cannot write? Because this voltage is okay, this voltage is okay, plus minus, but the question is what is the voltage here, plus minus? Well, it's a current source, 7 ampere, so you cannot write the KVL here. So you get my point. This is a problem you are getting, and that's why you have to apply the super mesh here. And in order to apply, because why? A 7 ampere current source, one side is I1 current is this way, another side, what is the current going upward this side? I3, right? This is I1 is coming down and I3 is going up. This is the main problem. So we have to apply the super mesh here. If you want to apply the super mesh here, because the current source is present in this way, that, listen, current source 7 ampere is present in such a way that on both sides of the current source, on the left hand side it is getting I1, on the right side it is getting I3. So it is filling two current in two sides, 7 ampere current source. You got my point? Hey, you understand it?
Sir, can you please explain it again?
Like last time, super node we apply, because remember this morning I told you super node we apply because 12-volt battery was in between two nodes, V1 and V2, node 1 and node 2. This morning I told you.
Yes, sir.
That's why you applied super node. But if the battery one side is one node and another side is ground, do you need to apply super node?
No, sir.
Remember, all of you remember?
Yes, sir. Yes, sir.
Forgot it. You forgot it. Is it exactly the same thing here? The current source, both sides having mesh current. One side is I1 mesh current, another side is I3 mesh current, 7 ampere current source. That's since both sides got two different mesh current, that's why you need to apply super mesh here. If, just I'm telling you, if it is something like this, all of you can look at it carefully. If it is something like this, that look, this is a current source, 7 ampere, and this is a voltage source, 7 volt. This is plus minus. For example, if it is, if we swap it, swap, you understand swapping? Interchange.
Yes, sir.
If we interchange it, then this is going to be the voltage source, this is the current source, right? In this case, this is not a problem, but in this case, I think the current source here, will it giving trouble, so that we have to apply super mesh?
No, sir.
No. The reason is, you can straight away from this, you can straight away say that I1 equal to 7 ampere. Why? Because this 7 ampere current source, both sides, one side is having mesh current, another side is not having mesh current, isn't it?
Yes, sir.
Only one side got
Yes.
mesh current, the other side is zero, no current, no mesh current, zero mesh current. So you can see a reference or something, zero, like that. So one side got mesh current, I1, another side got no mesh current. But when 7 ampere current source was here, at that time it was having two mesh current on both sides, I1 and I3. You understand the difference?
Yes, sir.
Yes, sir.
Okay, so when the current source is in the middle here, then you need to apply the super mesh. But when the current source is here, then you do not need to apply super mesh. Do not need to apply super mesh, because in the middle, 7 ampere current source, both sides
Sir, I have
having
a question from
two
live
different
class.
mesh current. That's why you need to apply. Who is that?
Sir, Saad bin Haider.
Sad bin Haider. Yeah, go ahead.
Sir, if there is on the side that current source and on the middle there is voltage source, I can straight write I1 equals to 7 ampere. Is it?
Can you repeat?
Sir, if there is 7 ampere current source is on the left side and the
Here,
there's a
left side means here.
yes, sir,
And
and a voltage source in the
here.
middle. Yes, sir.
Right, right.
Then I can write straight away that I1 equals to 7 ampere.
Yeah, that's the thing I told you.
Okay, sir. Thank you, sir.
Because of one side is I1 and another side is 0. So I1 minus 0 equal to 7. So that means I1 equal to 7.
Oh, okay, sir.
And in this case, if the current source is here, 7 ampere, then it is I1 minus I3 equal to 7. So none of them are 0. So I7 equal to I1 minus I3. And that's why you have to apply the super mesh over
Mesh,
here. In this
yes,
case.
sir.
Yeah, good. Super mesh. But if the 7 ampere current source is on the leftmost, then you don't need to apply super mesh because one side is having mesh, another side is not. It's just like the 12-volt battery source in the morning I have shown. Can you remember the one and node 2? That's why if the battery is one side node, another side ground, like this one, if the battery is like this, then you don't need to apply this. Super node do not need it. But here we need, because the battery both side got two different nodes. No one is reference node. Get it?
Yes, sir.
Okay, I hope that you understand it now. Now let us go back to the previous thing, what we were working with. Okay, I'm just going to wipe out with this thing faster. Okay, now if you need super mesh or not, tell me.
We need super mesh, sir.
Good, excellent. At least one got understand. Hey, rest of you, do we need?
Yes, sir.
Yes, sir, because 7 ampere is inside.
Yes, sir.
Yeah, both side I1 and I2. Good. Now, if we need the super mesh, then again, same way we have to do. How the super mesh should be applied. Remember, the same way we have to go for super mesh. If you want to apply, then first thing is this is making trouble, the current source. So you have to deactivate, like last time we deactivated the current voltage source. This time deactivate the current source. Deactivate the current source. Again, in order to, before deactivating the current source, what you have to do, you have to define the current. Hey, how to deactivate the current source? What to do? The current source should be what? Short. It's an open question to you all of you. I think be ready, but I am going to ask question. As you know that when I ask question, you have to answer the question according to the I mean, you have to raise hand and then I ask question and he will tell the answer. That way actually you have to answer. And if you even you know, but you are not allowed to tell me, otherwise you will get negative marks as you know that the system. So be careful about it. Now I'm going to ask the question to guys and he has to answer the question. Just going to tell you, this is the question to whom I'll ask, Mudassir Billah Nirjhor. Are you here, Nirjhor? Mudassir Billah Nirjhor, are you here? If not, I'm giving you absent here today. Hello? Okay. Absent. Mudassir Billah is absent today. Okay, then go for the next guy. Aniruddha Sarkar, Trishit, are you present? Trishit?
Yes, sir. Yes, sir.
Yes. Can you tell me how the current source can be deactivated?
Sir, we can short the current source.
We should short the current source. Okay. You remember last time 12-volt voltage source we deactivated in the super node. How we deactivated the 12-volt voltage source? V1 and V2, this 2 point, we deactivated the voltage source, 12-volt voltage source. Remember,
Yes, sir.
Trishit? How
Yes,
we
sir.
did it? How? Can you remember how?
Sir, we added to nodes.
Okay. Okay. You cannot remember maybe properly. All right. Abdullah Al Noman, are you here? Abdullah, bit faster.
Yes, sir. Yes, sir.
Okay. What do you think? How to deactivate? How we deactivated the battery in the super node? 12-volt battery.
Sir, 12-volt battery is short circuited was.
Okay. Now we are going to do apply super mesh, and we are going to deactivate the current source. So how to
It-
deactivate the current source?
By opening the circuit.
By
Open circuit.
open the circuit. So yeah, good. This is the way actually we have to deactivate a current source. If you open the current source, look at the cursor. If you open the current source, if you open means what? You take away this thing, you cut and take away. If you take away, there is no wire. If there is no wire, there will be no current, right? Hey, Abdullah, you understand?
Yes, sir.
And Trishit, you get it?
Yes, sir.
Okay, if you open the 7 ampere source, that means this one you take away means there is no connection, no wire. If there is no wire, then there will be no current flow. That means the current flow is 0. So deactivate the current source means 0 ampere current should flow through that. Now, Trishit, you said short circuited. If you short it, will the current be 0, Trishit? Hello? Trishit, can you hear me?
Yes, sir.
Will it be 0 or not? If you short it, if there is a wire short it, the current flow will be there or not?
No, sir. There will be no current flow.
If you connect a wire, short it. If you short means there is a path to Abdullah, what do you think?
Oh, sir, no, sir, no, sir. There will be, because there will be a path, but there won't be the source.
Yeah, so if there is a path, then current will flow through the path because there is a
Yes.
wire. If you short it means you are giving a wire connection here. Directly a wire is connected. That's
Sir,
why
if we remove the source, will the flow change?
no, if you remove the source, then it is empty here, right? It is empty, nothing here. If
Yes,
it is
sir.
empty, the current cannot flow through the air.
Yes, sir.
So the 0 ampere current is going to be flow through this circuit. That means current source is deactivated means 0 ampere current. Now you said Trishit, it should be short circuited. If you short it, that means
Yes,
there is
sir.
a wire connected. In that,
Yes, sir.
will it be 0 ampere?
No, sir. There will be
There is some current
sir.
flow, right? So that is not the way to deactivate a current source.
Yes,
Now we need to show that this is 0 ampere. It giving 0 ampere current. That means you have to open it. Okay.
Yes, sir.
Thank you very much. Now let's go. This is a very basic thing we all need to know. Okay, good. Hopefully everybody understood. Now let's go. Circuited.
No, sir. Open, sir.
Open circuited. Good. If you short it, a lot of current will go through that, right? 7 it will
Yes,
be
sir.
more than 7 ampere. So it is not short circuit. Rather, as your friend said, open circuit. It is the fact actually. So you have to open the circuit. If you open the circuit means, all right. Now we can say source at I1 and going up. Deactivate the current source 7 ampere. How to define the 7 ampere current source? 7 equal to what? Now, as you all understand, you have to open the short circuit. You open the current source in order to deactivate. Now, before opening, like last time, before opening, you have to define the 7 ampere current source. That means 7 ampere equal to what? That is the question. Trishit, can you answer this question? What will be 7 ampere equal to? Okay, Trishit cannot answer, right? Okay, now
Sir, please repeat the question.
I'm asking you 7 ampere. 7 equal to what? How to define the 7 ampere current source? 7 equal to what?
7 equal to what?
Last time, 12 volt voltage source. 12 volt equal to what? 12 equal to what? Written? Remember? No, then you cannot answer this thing. You should be careful in the class. Okay, I think I'm going to ask the next guy. Okay, Kaushik, can you tell me, Kaushik? Okay, Kaushik is not answering the question. Then Manoj Kumar Poddar, can you answer? Hello, can you hear me? Manoj?
No, sir, I can't.
Okay, good. Abdullah Al Sakib, if no, then you just tell me no, sir. That's it. I'll jump to the next guy. Abdullah, I'm giving opportunity to everybody.
Yes, sir.
Yeah. No, no or yes?
No, sir.
Okay, good. But carefully listen, the guy who answer, you have to understand it. Don't depend on copy paste in the CT2. You have to do it by yourself, remember. Amirul Ahmarul Islam Chaudhuri, can you answer? Yes or no? Don't waste time. Ahmarul, are you present? Okay. Tanvir Anjum, you cannot answer. Tanvir. Muhammad Faik Haidar.
Yes, sir.
Yeah, can you answer? 7 equal to what?
Sir, I think V by 2 ohm.
No, V is not here. Here we are having three current, I1, I2, I3 mesh current. So 7 equal to what?
Sir,
have-
sorry, I can't
Hey,
answer.
come on. Yeah, 7 ampere having two current in both side. On the left side, what is that?
I1,
On the right side?
I3.
And what will be the 7 ampere equal to? Any children didn't born can answer this question. I'm telling you now, you cannot think about it. Okay, no problem. You attentively, very carefully listen the answer people give you. Anamul Haq,
Yes, sir.
what is the answer? Yes, sir. Cannot. Okay.
I1 minus I3, I guess.
I1 minus I3. Why not I3 minus I1?
Sir, because the current
Because the current what? Hello?
that's why.
I'm
In the
sorry.
direction of I1, sir. In the direction
Good,
of I1.
good, excellent. Because the
I1
I1 direction is downward, 7 ampere also downward. So I1 is more than I3. That's why I1 minus I3 equal to 7 ampere. Excellent. So you will
Yes.
get 0.1. Thank you very much. Okay. Anybody? This is the current going down and this is the current going up. So 7 will be what?
7
I1 minus I3.
I3.
Yes, one current going down is, you said I1, and going up, what current going up? I3, right? This side, I3 is going up, I1 is going down, right? Hey, you all understand it?
Yes, sir.
Yes, sir.
Yes, 7 ampere left hand, yeah, 7 ampere left hand side, I1 is down, and 7 ampere right hand side, I3 is up. So which one? It will be the difference between the two current. Resultant current will be 7 ampere. So resultant current, because one is going up, one is going down. Either it will be I1 minus I3 or I3 minus I1. I3 minus
Sir, I1 minus I3.
I3 minus I1 or I1 minus I3. Why not I3 minus I1? You said I1 minus I3. Why not I3 minus I1? Hey, look, everybody. Go, answer.
So because
Sir,
the direction of
sir,
I1 and the current source is same.
kind of same, sir. Yes.
Right, good. Because the 7 ampere current direction is downward. What does it mean? Resultant current must be downward. And since I1 is downward, so it must be I1 minus I3. If you write I3 minus 1, there is a minus 7 ampere, opposite direction. So it should be the same direction of 7 ampere current. 7 ampere current is downward and I1 is downward. So I1 is greater than I3, should be. And that's the way we have to write. So it should be like that. I1, you have to do, now you deactivate it. Deactivate means you take it off. Now off it. Off it means this is open. If you open it, then you can now see. If you open it, then the loop or mesh become very big. The loop is becoming like this, the blue one. You go like this, 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 and here. So this is becoming a very big loop now. If you open this 7 ampere current source, then this whole line is going to be open. This whole branch is open. And then this is the big mesh coming. That's your super mesh. And that super mesh is going to be like this. If it is the super mesh or a big mesh or super mesh or the big super mesh, the big mesh means the KVL or the, what do you call it?
Sir, I have a
What will
question
be the
from
KVL
Live
now
class.
for the super mesh? You have to write. So is it from the live class?
Yes, sir, Live
Yeah,
class.
who is that? Sure.
Muhammad Faik Haidar.
Yeah. Yeah. Tell me, what is your question?
Sir, if we open the circuit here,
I mean the 7 ampere source.
yes, sir, then
Hmm.
the 2 ohm resistor, it
Is
will be,
it will be redundant.
so it will be cancelled out.
Yeah,
as
it will be
well.
cancelled out. Yeah, because it's isolated from the circuit. Because if you disconnect it, there is no wire connection between. You can connect a resistor here and open it up to this. This is open, so it is dead. No current flow through. That means it is dead.
So in that case, the
Hmm.
voltage of the circuit, will it be same?
What
Voltage
voltage?
or
Voltage? No, now the if you disconnect this current source, that means, listen carefully. That means this whole branch here, the whole branch means this thing. Can you see my cursor?
yes, sir.
The whole thing here, this whole thing will be taken away.
Yes, sir.
Same thing. You leave it here or you take it here, all the same. With the whole branch, this two element, the current source and 2 ohm resistor, both are inactive, right?
Yes, sir.
In that case, the blue loop, can you see?
Yes, sir.
This is
Only
becoming
this
the
circuit
yeah,
will work.
this is becoming the big loop. That's
Okay,
a
sir.
super mesh or super loop.
Okay, sir. Thank
Okay,
you.
KVL,
We
how many
understand.
voltage? How many voltage?
4 voltage, sir.
Sir, we can't hear you.
Your video is freeze.
Oh, I'm sorry. Okay, I'm sorry. No. I think I'm asking the question to Seksadi. How many voltages are there? Seksadi, can you answer?
Sir,
How many voltages are there in the mesh loop, in the big loop? How many voltage in this big blue loop? Because you have to apply KVL. KVL means all the voltage will be added together, right?
Yes,
Sadi?
sir.
How many
Yes, sir.
voltage? How many voltage there?
2. So 3,
Yeah.
sir, 4, sir.
Right. So this is the answer, 4 voltages. Now you have to tell me the KVL with these 4 voltages, right? So
Yes, sir.
start from here. If you go start from here, 7 volt is the voltage rise or drop?
Sir, right, sir.
Voltage rise. So what you should write, +7 or -7?
Sir, +7, sir.
Good, excellent. Now you get 0.1 marks. Thank you very much, Seksadi. Alert,
Yes, sir.
sleeping or then I cannot give the marks. Okay, now next got, because we are going to write the KVL. And next fellow is Tanvir Islam. Are you there, Tanvir?
Yes, sir.
Okay, now tell me the full KVL. Sadi said it is +7 volt. After that, 1 ohm, right? This is the voltage. What is that voltage?
Sir, 1 I on
1 I1.
minus 1 I on, sir.
Then what happened? There is another current I2 on the other side, right? Last class, what you understand the mesh current voltage. This is a plus and minus across 1 ohm resistance. So 1 ohm is experiencing 2 current, right? One is I1, another one is I2.
Right.
And what is the voltage then? Last class we have, remember? You cannot remember.
I1 minus I2, sir.
What? Can you repeat?
I1 minus I2, sir.
Yeah. What into? 1 into 3
1,
into
sir, 1.
1 into I1 minus N. Now, can you tell me the equation again? 7
volts, sir, minus
7 minus, right? Good. 7 minus 1 into I1 minus I2.
I1 minus I2.
Just a minute.
4 voltage, sir.
4 voltage, and then we'll minus 3 into I and off, and then we'll take a break for 15 minutes. Minus I3. Sorry.
4 volt.
Sir, can we
I1
take a
minus
break?
And then we'll take a break for 15 minutes. After prayer, we are going to start. Just go ahead, listen, and then I'm finishing now. And then we'll get a 10 minute, 15 thing. I'm not asking you a question. I'm not asking you a question. Then next one is be 3 minus. Okay, now can you go for the next voltage? Hello. Tanvir Islam, what happened?
Yes, sir.
What is the
Yes,
next
sir.
voltage? What is the next one? Can you see the cursor? 7
Yes,
minus
sir.
1 into I1 minus I2 you told. What is the second voltage? The third one.
So third one is minus 3 into I3 minus I2.
Beautiful. Excellent. 3 into I3 minus I2.
I2.
Beautiful. And then where is then the fourth one will be what?
Fourth one is minus I3, sir. I3
Absolutely. Absolutely good. And the fifth one will be?
Where is fifth one, sir?
Where is fifth one? My question to you then, what to do? Whole thing
The
equal
whole
to?
thing, the equation is finished, sir.
Question finished. So what
Minus
to do?
0, sir.
Equal to 0.
Equal to 0. Good. That's what you have to tell me, that no more voltage means it's equal to 0. Good. Excellent. You get 0.1. Thank you. Into, now you already understand, minus 3 into what? 3 minus 3 into what? I3 minus I2. I3 minus I2. Okay, minus 3 into I2 minus. Then you got 1. The minus 1 into I3. I3. Full stop. After that, no, nothing, then equal to 0. These are the, how many voltages you can see? Some of you told me already. 1 volt is here, 2 voltage, 3 voltage we have got for the super mesh. Up to this, we are getting it. And next thing is, we are going to come back and write the next equation from the green circle. This is the green circle we are going to get. Okay. This is the green circle. We have to, this is another loop because we need 3 loop because 3 unknown, and this is another loop. This loop you have to find the KVL from. Okay, all of you understand that there are 3 unknown is I1, I2, I3. We have to find 3 unknown, well, 3 current. So you need 3 equation. One equation from the definition of 7 ampere, I1 minus I3. Another equation is this one. Just now we got it, which is also in terms of I1, I2, I3. So we need 3 equation for 3 unknown. And the third equation will come from this small loop. And this small loop, we have to apply the KVL. And what will be that KVL? Who can answer? Raise your hand, please. Go ahead, faster. Okay. So first answer, raised hand by Samit bin Hassin. Samit,
Yes,
you start.
sir, first of all, minus 1 into I2 minus I1. Hello.
Okay, yeah, go ahead then.
Minus 2 I2.
Then?
Minus 3 into I2 minus I3 equal to 0.
Beautiful. Excellent. Thank you. This loop, I think we can easily find it. Okay, this is your KVL 3. KVL 3. And that's can give us the solution to this problem. I can keep it up to this, and next, after coming back from the break, we'll see 3, and that's all about what time we are coming. Okay, now if you go with this, then we can see that equation for the KVL 3 can be written as, we cannot have a space to show. Okay, I'm just going to wipe out that part. I2 minus 1 into what? Minus 1 into I1, I2 minus I1, I2 minus I1, right?
Yes.
Okay, then next coming there, 2
Minus 2 I2.
2 I2. Then next,
Minus 3 I2 minus I3.
right, minus 3 I2 minus I3. I2 minus I3 equal to 0. So these are the 3 current you can get, and that is equation number 3. So equation number 1, equation number 2, and this is equation number 2. Okay, equation number 2 and equation number 3. These three equations, if you look and if I take it, oh, you cannot. Okay, three equations. If you get these three equations, from these three equations, you can find the answer on the whiteboard.
Sir, I have a
Done
question
or not?
from
Otherwise,
Lec10.
okay. 2 ampere. Okay,
Sir, I had a
so
question.
this is the value
Lec
you
plus.
should get. Yeah, go ahead.
Sir, from the third equation, why is it starting with a minus? Like -1 into I1 minus I2, like that?
Okay, you're talking about this one, right?
Yes, sir. The
Okay,
first.
okay, I'm going to tell you, listen. It is because everybody know that if you go this way, can you see the cursor?
Yes, sir.
If you go this way, then this is plus, the current entry in this way means that this is plus and minus, plus, minus, plus, minus, right? So if you go this way, then 1 into, and this side, you are in this loop means I2 will be more than I1, right? So 1 into I2 minus I1 will be the voltage drop here. And that voltage, this is plus, this is minus, this is plus, this is minus. What is that? Voltage what? Voltage drop or voltage rise?
Drop, sir.
If you say voltage drop is negative, that one you have done, because this equation 7 is plus, because we assume a voltage rise here, right?
Yes, sir.
That's why positive 7. But when you come here 1, then it is gone downward direction. That means this is plus and this is minus. That
Yes,
means
sir.
this is voltage drop, and that's why -1 I1 minus I2 we have written, right?
Okay, sir.
Why you written plus and minus? Because voltage rise, voltage drop. But in this case, all our voltage drop, isn't it?
Yes, sir. We just invert the whole loop.
Oh yeah, but if you say all are positive, not negative, I assume, or you invert it, it should be the same thing. No, and because both sides, if you multiply by -1, it is the same thing, isn't it?
Yes, sir.
You said that all in recursive way as also it's a thing we have seen earlier also. So if you assume this is the way we are moving, this is plus minus plus minus plus minus, and we assume voltage drop is negative, then you put all negative. So it is a conventional for this equation 2 and equation 3. You will not be confused, because in equation 2 you consider voltage drop is negative. In equation 3 you also consider voltage drop is negative. That's why you put all negative. If you put all positive also no problem, because both sides you got -1. If you multiply, you get the same thing. So this is the reason why we put all -1, -2, -3, because we assume all voltage drop. You understand now?
Yes, sir. I got it.
Okay, good. Now answer, all of you try to understand. I'm giving you the answer directly. This thing, can you see these answers? Hey, can anyone, I told you last class that please learn how to find this answer using programmable calculator. Can you tell me who learned it? Raise your hand. Who learned using the programmable calculator how to calculate this I1, I2, I3 from the three equations? Can you please raise your hand who learned this thing? Good, excellent. I see a lot of hands raised. Now my question to you all, those who did not learn, because you don't know, you can ask these guys, those who did it, those who learned, and worst case scenario, you can ask the student tutor. She can also help you to learn this thing. All of you need it tomorrow. Otherwise, you cannot answer the question tomorrow in the CT2. I am telling you again, you have to learn it. UMUST. Otherwise, you cannot answer. Remember, three equations you have to solve. And if you use your programmable calculator, it will be very fast to do it. You can save a lot of time and you can submit the answer in time and get good marks. I'll give you full marks if you can use your calculator and can get the correct answer. You don't need to show me by using the Cramer's rule and how you found it. Okay, I hope that should be fine. Everybody understood the answer now. Okay, that's the way you have to solve this problem. I hope that you already got it. Well, we can go for the go to solve the problem like this type. Okay, now look at it. How to solve this problem? Again, Open question to all of you. All of you start solving this problem by yourself the same way in the last problem I have shown. And if you can solve the problem, get the answer is given there in the bottom, you say minus 1.03, you get full 1 mark. All of you please go and try. Answer is minus 1.93. What is your question? What question? Question is I1 equal to what? You have to find I1. So if you want to find I1, I2 and I3, you have to assume. Here you can assume I2, here you can assume I3. Then you have to find the mesh current, everything you have to do, super mesh and everything, and then you get the answer. 3 equations you have to write correctly, and then you find the answer. Go fast. The guy who can answer the question correctly, he get full 1 mark. Once you've done it, raise your hand. Hey, who? Majid Hussain, have you done it already? Lower your hand if you don't. What happened? Majid, have you done it?
No, sir. Actually, I forgot to lower my hands.
No, it's okay. Go ahead. First, all of you try your best to do it. This is something like a class test, you can imagine. So in the class test, you have to solve it by yourself. Now you see whether you are capable to answer to the question, or you are the dependent duck that other people will do it and then throw the messenger copy paste. All kill your life. Remember, you have to try, at least you have to understand how to do it. That is your benefit. When you get the certificate, at least you know how to do it. This is very important. Marks is not always important. Please, all of you, give your thought. Okay, I'm giving some hints. You can have a look. There are 3 loops. Yeah, but you have to go for what is the questions. Question says that what is the I1 equal to? If even I1 equal to what? You have to go for 3 loop current, like the last time I show you one of the problem, exactly the same way you have to go. Okay, so if you do like that, maybe you can think like this, and the value is I3. This is, let's say, you can say this is I2 and this is I3. If you consider, then this 3 I1, I2, I3 and I1 you have to find, but you have to go for 1 by 1 loop. And if you go for this loop, can you apply the KVL? Cannot. Why? Because of the current source present, and current source 3 ampere is having both sides. So you have to apply super mesh. You're right. Now, if you want to apply the super mesh, you have to deactivate the current source, 3 ampere current source. How to deactivate? Before deactivate, what you have to do? You have to define, right? You have to. Okay, go ahead faster. 3 equations. 3. I mean, one is coming from the definition of the current source, super mesh. And the other 2 equations, one super mesh equation, another small loop equation. Exactly the same way what I have shown you in the last problem. If you still you cannot solve, then you could not understand the last problem. And if you could not understand the last problem, then you are meaningless to study here. Please try, everybody, please try. Don't sitting down doing nothing. Okay, if anybody had written 3 equations, also I'll give you 1 mark. So once you complete 3 equations correctly, you raise your hand. Okay, fine. Enamul Haq Ryan. Okay, you give me the answer, Enamul Haq Ryan. The first equation, what is that, Enamul Haq Ryan?
First equation is 3 is equal to I1 minus I.
You out from the challenge.
Sir,
Look at 0.
Sir, I'm done.
Okay, I think Ryan, you are wrong in the beginning. Okay, now next is Fahim
Sir, I'm
Fayaz.
done.
Yeah, Fahim Fayaz. I'm talking to whom? Fahim Fayaz. Can
Yes,
you?
sir.
Yeah, go.
Yes, sir.
First equation. First equation.
Sir, Shaurukh Kumar.
Yes, sir. Sir, I1
No,
minus I3.
I'm sorry. I saw according to the sequence, Fahim is going to be the next.
I1 minus I3 equal to 3, sir.
I1 minus
I3
equal to 3. So
Three,
you are,
sir.
yes, sir, you are out from the challenge as well. Now, next, Jarif Jaman.
Yes, sir.
Go ahead.
Sir, 3 equal to I3 minus I1. This is my first equation.
This is your first equation because I3
Yes,
is upward direction and
yes, sir.
I1 is downward.
One is down
So it should
direction.
be I3 minus or not I1 minus I3. All of you, those who told me I1 minus is wrong. Okay, it is I3 minus I1. You are correct. Then what is the, who is the dark talking to me? Hey, who is giving the answer?
Me. Sorry, sir.
Jarif, okay.
Yes,
What
sir.
is that second equation? Super mesh. Tell me.
Sir, so for supermesh, sir. Supermesh, so final equation is minus
No, you tell me,
4I1.
madam. You tell me this is the super mesh, right?
Oh, yes, yes, sir.
You tell me the step by step. Start from here and go.
Step by step. Yes, sir. Sir, plus 10.
Yes, sir. Go ahead.
It's a plus 10 minus 4 into I1 minus I2 minus 10 into I3 minus I2 minus I3 minus 7 I3
Then
equal to 0.
good. Okay, now we'll go for the third equation.
Yes, sir. Minus 4 into I2 minus I1 minus 5 I2 minus 9 I2 minus 10 into I2 minus I3 equal to 0.
Excellent. Good. Now, did you find the answer?
Sir, you told up to the equation.
Yeah,
so
I know
didn't-
that, but you don't know how to use the
Yes, I can use a
programmable
calculator. And yes,
Okay.
sir, I can use.
Okay, you find the answer. That is the second question. All of you drop your hand and calculate the value of I1 and get, I think all of you should get the same answer. You can tell me if anybody got the answer. Anybody got the answer? One minus
Yes,
1
sir.
point. You will be caught if you tell me the wrong. Are you, who is say yes, sir? I'll catch you. Who?
Sir, Shaira.
Tyra. Okay, you will be in trouble now. Tell me, the equation number 2. What is the simplified version in terms of I1, I2, and after simplification? What is the equation number 2 you got?
Sir, minus 4-1
Okay,
plus
just a minute. I'm writing it down. Yeah, tell me what is that?
minus 4I1 plus 14I2
40I2
minus 18I3.
minus 18.
Yes, sir, 18.
80 or 18?
18
18I3
equal to minus 10.
minus 10. And what is the third one? Third equation, final equation.
So simplified.
Simplified. Third simplified equation.
4I1
4I1
minus 28I2
28I2
plus 10I3
then I3 then
equal to 0.
all right, good. Let us see your, and is she correct?
Define
Anybody got the answer?
Yes, sir.
Yes,
She's
sir.
correct.
Good.
I've also done it.
Now all of you note it down and I'm going to show you here. This is the super mesh. As you can see, the super mesh equation here. All of you have that understand. This is the way the KL3 equation you got. These are the 3 equation. All of you take the snapshot. As your friend said, I'm going to give Saira 0.1 marks. Saira, and what is that? Jarif, right? Jarif given the answer.
Yes, sir. Yes, sir.
Jarif, yeah, Jarif gets full 1 mark. Thank you very much, Jarif and Saira. Both of you given the correct answer. Thank you very much for the right answer. I hope both of you are quite able to answer in the final exam. I'm sorry, in the CT2 tomorrow. But tomorrow class will be node analysis, mesh analysis. This is the mesh analysis thing we have seen. So you cannot think like that. Okay, now all of you jump to this problem. All of you ready to answer this question the same way we are going to do. And look, I'm going to talk about this problem is saying that, okay, now look at it. Problem. It is a little bit critical, but there's an independent source. Okay, in this problem, we are going to solve this problem. We're going to find the value of all of you. Can you listen? Can you hear me? Hey, live class, can you hear me?
Yes,
sir.
Okay, listen. This is the problem now we are going to solve. You all follow me and ask question. You get the marks. Well, what we're going to find from here is we're going to find the value of I1, I2, and I3. Now let us go how to get these values. That is, we are going to apply some equations and go and turn like that. Now, first thing first, we are going to go for I1 value, and anywhere I'm talking to the guy you look at it. I'm going to ask the question to someone like Kaushik. Kaushik, are you there? Kaushik, are you here? Muhammad Kaushik. I think Kaushik is absent today. I'm writing absent. Okay. Kaushik, I am assuming you absent. You write in the chat box if you cannot talk to me. Okay, now next gut is Abdullah Al Saqib. Can you answer this question? Abdullah Al Saqib, I1 equal to what? The question is I1 equal to what? Saqib.
Yes, sir.
What is that? Abdullah Al Saqib, can you tell me I1 equal to what? I1 value? I1 is flowing through the loop.
Sir, 15 ampere.
Beautiful. You get 0.1. So simple question, and you did good way the answer. Excellent. I'm giving you 0.1. Thank you very much, Abdullah. Now the next thing is, let's go follow the instruction. A dependent source present here, and again the same thing. If you go for I1, any children straight away can tell me the answer. What is that?
15 amperes.
Exactly. I1 is 15 ampere. You get some marks. This is equation number 1, and you get some marks. That I1 value is nothing but straight. Okay, I'm talking about in a live class. I'm talking about in the exam. If you write I1 equal to 15, that means out of 3 current, 1 current answer is correctly you given, means you deserve some marks in the exam. That's what is the thing. Okay. Away 15 ampere. Everybody, I hope that understand it. Why I1 is 15 ampere, right?
Yes.
Like last time I4 equal to 8 ampere, the problem we solved like that because the outer current source is in the outer side. So it is straight away you got. That's one thing you got. Another one, you see this is the current source which is making trouble because you cannot write down the loop because of this current source, and the current source is having 2 mesh current in both sides. So super mesh thing is going to be thought about. But if you go for super mesh, also you cannot write the equation because of 15 ampere current source is there, and this is becoming much more critical. You are going to deactivate it. Okay, fine. You deactivate it, but before deactivation you have to define it, right? And if you want to define, hey, what will be the definition? Can anybody tell me?
Hello.
Hello, sir.
Hello, sir.
I'm sorry, Faik Haidar, are you present?
Yes, sir.
Okay, I'm asking you this question, very easy to get the marks. How to define this current source? What is the value of the current source? The value of the current source. Hey, what is that?
Sir, this will be I3 minus I1.
I3 minus I1 equal to
Yes,
what?
sir. Equal to 1 by 9 Vx.
Absolutely. Who is this? Is it Faik Hussain?
Faik Haidar, sir.
Faik Haidar. Excellent. How come you answer this question? I have a very bad impression about you, but now it
Sorry,
is
sir.
going to be open. So good. I think very much very good answer you have given. Thank you very much, Faik Haidar. Okay, now let's come back to the point. Your answer is correct. It is I3 minus I1 because I3 upward direction, the current. So it's okay. 1 by 9. What is the current value? 1 by 9
Sir, is equal to I3 minus I1.
Why say why not I1 minus I3?
Because we know the current in the same direction minus current opposite direction.
So the current is upward direction, I3 is upward direction. So I3 will be higher than I1, and the I3 minus I1 will be 1/9 of these things. That's the reason, because the current source direction, right? I3. If I ask you what is Vx, look at it. Vx is the voltage across 3 ohm resistor. All of you understand?
Yes.
Yes, sir.
Now I am asking the open live class. Yeah, I'm going to ask the question to what do you call that? Abdullah Al Saqib. Abdullah Al Saqib, can you answer? Vx equal to what? The voltage across 3 ohm resistor. What is the equation? Vx equal to? You have to apply Ohm's law, right?
Yes, sir.
What is that? Can you? Okay.
Sir, Vx by 2 ohms.
Vx by 2. Okay. Now I think this is not correct. I'm going to. You think it's still? I have time. You have a chance to go. Now I'm asking this guy. Hey, Ahmarul Islam Chaudhuri, can you answer this question? Ahmarul. Okay. Manoj Kumar Poddar, can you answer?
It's 3 into I3 minus
Who is answering?
So Manoj.
Manoj. Okay. Tell me what is the answer?
So 3 into I3 minus I2.
Why not I2 minus I3?
So both are the downward. So
What do you mean by downward? The current I3 minus I2 you told, right? I3 minus I2 is going
Yes, sir.
from the left to the right or right to the left?
so I3 so I2
I'm sorry, you try to get the
it's
point.
gone from I2.
It's go no. Can you see my cursor?
Yes, sir.
Okay, the current flow through the 3 ohm resistor is from the left to the right or from the right to the left. This is positive, this is negative, Vx plus and minus, remember. So the current flow is which way? From the left to the right or from right to the left? Manoj?
So plus to minus.
Plus to minus. So what? Left to right or right to left? I'm asking you the left to right or right?
Left to right, sir.
So why you are
Left to right, sir.
Okay, if the current flow left to right, that means this way the current flow. If the current flow is this way, then it will be what? Which one? I2 minus I3 or I3 minus I2?
So it's I3 minus I2.
Not if it is I2 minus I3, that should be left to the right, isn't it? Because I2 is more than I3, then it is from that direction.
Yes, sir.
This is left to right means that current I3 will be more than I2. That's why it is left to right. So left to right means I3 minus I2. So your current flow through the 3 ohm resistor for this Vx, this is plus and minus. The current should be from left to right means that means I3 minus I2 through the 3 ohm resistor. So Vx is 3 into the current is I3 minus I2. That's why, that's the reason why you say. But I know you heard it from your friend in the class and you told me, right?
No, sir.
Oh, no, sir. Then why you cannot answer? Why you said that?
I just fumbled, sir. But
Okay, no problem. Anyway, you give you 0.1 marks. Thank you very much. Okay. You have to answer, justify. When you answer, you have to justify why you say it. Good. I think that is the correct answer. I hope that all of you need to listen this carefully. Now, can you tell me what is the current flow through 3 ohm resistor? What is the current flow?
Yes, sir. 3 into I2 minus I3.
Okay. Why you say I2 minus? This is the question. Because Vx and 3. Vx equal to 3 into the current. But current will flow in this way, right? Because that is positive. Associate law said the current should be in that direction. If it is the current flow direction, then it will be I3 minus I2, no, I2 minus I3.
So I3 minus I2.
Hey, all of you understand?
Yes, sir.
Yes, sir. Good. So this should be I3 minus I2, not I2 minus I3, because the associate law will fail in that case. And that cannot be positive negative. It's a given there, positive negative. So your current will be in that direction and that current will be I3 minus I2. So this is what your Vx equal to. Now you tell me if anybody could not get. And you understand? I can proceed. Any question can ask me. You're right. Okay.
Sir, tell me the 3 ohm part again. Can you repeat it?
I'm sorry, come again. So what can we say? We can say our target is to find Vx. So what can we say? We can say the 3 ohm resistor, the voltage is Vx, current is I. So 3 items we can take together, and what law? Hey, got what law?
Associate law, sir.
Ohm's law. Ohm's law said what? Ohm's law said what? Ohm's law said V equal to IR. Yes or no? R is what? 3.
R is 3.
Hey, you understand? The red one, this black one, the green one, green one. Do you understand it now? The
Yes, sir.
Okay. Now question is, I is what? I is what? I is going through this direction, through that direction, and that's why it is positive, right? I will be enter into this way. I will be what? I direction is that. It will be I2 minus I3 or I3 minus I2.
I3 minus I2.
Because yes, sir. Because I3 is must be higher than I2. Otherwise, I direction cannot be from left to right, and it has to be from left to right because Vx positive terminal is this. So the current must flow through the positive terminal, and that's why red I should be I3 minus I2. If the red I comes that direction, then it will be I2 minus I3. You understand it?
Yes, sir.
Otherwise, if you cannot understand, then I think you can talk to ST. ST can explain to you. I am becoming mad. This is
yes, sir, I can understand.
Okay, then you can simply write 3 minus I2. Same thing. Okay, so that's all about your this equation. Now Vx, this Vx value we are substituting here. If you substitute Vx here, then you are writing here 3 into I3 minus I2 equal to what? 9 into 3 cancel out. You can just write 3 is taken off. I'm writing it. Okay, I'm writing like this, then better. I3 minus I1. Okay, now you can go with that like this, and final equation is coming like that. 3I3 and I3. 2I3, isn't it? Okay, I'm just writing I3 minus I2. I should write it in one line, but I'm writing still the same. And 3I3 minus I1. I'm just writing like this. So I can write here. Hey, the red I, you don't need to confuse, because for your friend to understand it, I have used that. I think don't make a mistake with that. Are you confused about the red I? Anybody? Shall I delete it? It will be better.
Yes, sir, it will be better, sir.
Okay, I understand your short circuit problem. Now, listen, you are all are saying, I think now it's all right. Good, no problem. Blue tone, KVL. Okay, now let's come back to the point. Let's come back to the live class. You have to be ready to answer to the question for the third loop equation, the blue loop equation. We don't need to apply the super mesh here, because super mesh, if you want to do, open this thing and you want to apply the KVL in this loop, you will be in trouble because of this is the current source. You cannot get the voltage drop here. That's why without super loop also we can find the solution to this problem, because I1 is 15 directly given here. So two equation you need for finding the other two value, I2 and I3. That's why another equation is important, which can come from this small loop. Now, what is the equation for a small loop? That is the next question. Yes, sir. Can Amirul Islam Chaudhuri, are you there, Amir? Ahmadul Islam Chaudhuri. Ahmadul Islam Chaudhuri, are you there? Hello, Ahmadul Islam Chaudhuri. You are caught. That means you are in the room and you left away, right? Ahmarul, are you present in the class? Okay. You're absent. So I'm just writing here. Ahmarul is absent.
Sir, can
Okay.
I
No, just wait. Yeah, Laboni, I'm sorry, Labi Brokoni. Can you answer?
Yes, sir.
Yeah, what is that?
Sir, it will be, sir, minus 1 into I2 minus I1 minus
Yes,
2I2
right,
minus 3 into I2 minus I3 equal to 0.
Absolutely good. Thank you very much. So you get 0.1. Now, you all understand the third equation is like what Connie said for the blue. Okay, KVL B. We
I2
have
minus I3.
I2 minus 3, I2 minus I3. I2 minus I3. Then minus what?
is equal to 0.
Equal to 0. So this is equation number 3. Okay, all of you got the 3 equations. Now all of you start solving the problem and find the answer of I1, I2, I3 from here using programmable calculator, and raise your hand when you get the answer. After 30 seconds, not now. You have to, hey. Okay, now I'll tell yes, and then you have to start. Just 30 seconds. Okay, you can start now. If you solve, you can raise your hand. Yeah, now who is that? I think 30 seconds already gone. Now anybody, only one person raise hand. Any other people? Because if he cannot answer correctly, then the second guy will be taking opportunity. All of you please try. Okay, second guy comes. First one is Abdullah, then Imtiaz. And I need third one. Then we can start. Any third person? Just use these 3 equations and find the answer. Okay, I think we can start. Abdullah, what is your answer?
Sir, I2 is 11 ampere and I3 is 17 ampere.
Okay, Iftikhar, are you getting the same answer? Imtiaz?
No, sir.
Okay, what is your answer, Imtiaz?
Sir, I2 equals to 7 ampere and I3 equals to 19 ampere.
All right, and the third person raised hand. Who is that? Atikur Rahman, I'll kill you. You just listen and you give him the answer, right, Atikur?
No, sir. So I was doing.
Okay, you tell me who is correct. Imtiaz or Abdullah, who is correct?
Sir,
or you got a third answer? Third answer?
Yes, sir. Yes,
third
sir.
answer, okay. What is your answer?
So my I2 is minus 11.67 ampere.
Okay, good, no problem.
And I3 is 28.33 ampere.
At least you have done it by yourself. That is understood.
Yes, sir.
Good,
I did.
no problem. Everybody need to learn. Okay, Abdullah, all of you, I have a lot of student hands raise hand. Abdullah, can you read your answer? All of you listen carefully. Abdullah, read it. What is your answer?
Sir, I2 is equals to 11 ampere and I3 is equals to 17 ampere.
Okay, those who raise hand, anybody got the same answer? Nobody got the same
Yes,
answer.
sir. I got the same answer, sir.
Who?
Majid Hussain, sir.
Majid Hussain. Okay. Now, Imtiaz, what is your answer? Read it.
Sir, I2 equals to 7 ampere, I3 equals to 19 ampere.
Okay, are there anyone got this answer? No. So Abdullah got one support and Imtiaz has no. Now let's come back to the point. If the answer is correct, Abdullah, then you will get 0.25 marks because you learned how to find the is it you use the programmable calculator and find the answer, Abdullah?
Yes, sir. I used.
Okay, that one I want to check. Good. You'll get 2.25 marks if it is correct. Let us see. This is equation number 3. That's it. You equal to 0. So you are thinking like that, but you cannot, because this super mesh equation cannot get. Can you get the KVL?
No, sir.
Super mesh KVL because of this problem. This is the current source. This current source is making trouble, right? What's the?
Yes, sir.
Right. And without it, this equation actually giving you, I'm talking about the I1, and even we cannot find it because to solve this 3 equation, put into the other 2 equations. Anybody done it? No, not yet. Check the answer. Yeah, I3 is, what is I3?
15.
Wrong. Any other? This is straight away 2 equation value you can find. You all are waiting. Lazy people. This 3 value you have to find and go. It will automatically cut and then go. I1 is 15, but I2 and I equation, and then no.
I3 minus I2, so it should be I2. You write that I3 minus I1, but it should be I2, I3 minus I2.
Oh, I3 minus I2 I have written, not I1. You thought it is I1. You thought you consider this is I3 minus I1. 2, not I. Not 19. No, it's what?
Yes, sir. Sir, I2 11, sir.
Right. I2 is 11. Good. Now the answer is correct. How come? Because of you consider all that one is a I1. and all you got the wrong answer. That's why. Okay, fine, no problem. This is a very simple thing, and this is 17 ampere. So these are the two answers you can get for this problem, and I hope that all about. Okay, now let's come to the live class. Is it Abdullah, your answer?
Yes, sir.
11 and 17. So Abdullah got 0.25. I think that's all for today, and I don't want to Abdullah 0.5. Okay, no problem. 0.25. Okay, now that's all. We want to stop it here, and our next topic, I told you that we are going to go after finishing this. We are going to go with the superposition theorem. Can you see the screen? Hey,
Yes, sir.
Okay, now do you want to continue with superposition theorem for another 15 minutes time, or you want to switch to the next class, the superposition? What do you
I have
think?
a class to join.
Okay, good. So I think no one want to go for today's continuation, right? We want to stop it here, right?
Yes, sir.
Yes, sir.
All right, no problem.
Yes,
Because
sir.
then I am going to do that definitely. I'm not going to go ahead with it. Now I'm just